Okay, forgive me for having such a lengthy teaching session this week. Probably should have divided this up linear one week and exponential the other. But anyway, this is the last one. I'm going to go really quickly because I'm determined that video number 3 is it. Number 9, watch video 1 and 2 if you have not already. Number 9, an assignment is worth 350 points. Each day the assignment is late, the professor deducts. Okay, deducts lets me know that this is going to be a decay problem because I'm going to be subtracting 10 points every time that the assignment's late. This is my current policy. I don't use the point system, but I do deduct 10 points. Write a linear function. Okay, so they told you it was linear. I know I'm going to use y equals mx plus b. And let's see, M is the rate of change. Well, your grade is going to change by 10 points per day if you are late. Now, it's going to be a negative 10 because I'm going to take 10 points away from your grade. Then X is the number of days that you're late, which we don't know. And everybody starts out with a positive 350 points. So that would be a plus 350. And then the 10 is negative because the numbers, I'm taking points away. B, how many points does the student have if he or she turns the assignment 1 week late? Well, 1 week is the same as 7 days. So I need to go to my formula, and where I have my X, I'm going to plug in a 7. And you can just straight up type this in your calculator. Your calculator should be able to handle these order of operations. So we know negative 10 times 7 is 70 plus 350. Yeah, I just typed that straight in my calculator and it can handle the order of operations. So the answer is 280 points. Whoops, 280 points. You would have 280 points if you were a week late on an assignment. Number 10, the cost of renting a moving van for a day is the initial cost. Okay, keyword, initial cost. This is your starting value. So I already know that's my B. I can go ahead and put 59 at the back because I know 59 is my starting value. It's my B. It's my y-intercept. Plus 35 cents per mile. Well, this is the rate. Remember, we've already had a test on rates, actually. Rates typically use the word per. So right here is 35 cents per mile. So that is my slope. So 0.35 is my slope. It's my rate. And then I put an X after my slope. And there we go. Now, one thing to note about this one, you see how they used C of X? Why do you think they used C? Well, I don't know, but I think it's because they're representing the cost, and C starts with cost starts with the letter C. This is function notation. Do not get freaked out when you see a letter other than Y. This is just function notation. The ones that we've done prior to this example, I believe, had F of X, and that's pretty common, but sometimes they'll throw a letter in there other than F that pertains to the particular problem. So I feel like they used C because they were talking about cost. Same thing for number 11. The cost to attend a school is one-time fee of $2,500 and an annual cost. Okay, you got to read this one carefully. This is a one-time starting fee. Maybe this is like the application fee or something. I'm not sure. But this is the one-time starting fee. Now, this fee right here, this is a rate. This is the rate per year to attend this school. So this is our slope, rate per year. This is our starting fee. So it would be 15,000. That's your slope. Slope is followed by X plus $2,500. And again, this is function notation. They used C instead of F because they're talking about cost. Number 12, find the slope and the y-intercept of the following linear equation. Well, this one is very similar to the very first problem we did where the girl made $21 an hour. I can't remember her name. Okay, we don't have a constant. We don't have a number at the back. There is nothing back here. Therefore, our y-intercept is 0. So M, our slope, is 3/2. That's the number in front of X. And our B, which is at the back, our y-intercept is 0. So M is 3/2. M is the same as the rate of change. Our y-intercept, they want it as an ordered pair, so it would be 0, 0. And the y-intercept is the same as the initial or the starting amount. You can use either one of those words. Number 13. Okay, this is the most challenging problem on the sheet, on the notes. Bacteria in a bottle are quadrupling. Now, you have to know what that word means. If you have quadruplets, then you had 4 babies at one time. Quadruple means 4. If the number of bacteria in a bottle at 3:30, okay, this is our starting time. So the bacteria started out at 3:30 p.m. That's important. And the starting number of bacteria is 5. So this is what we started with. This is our initial value. And the time that we started was 3:30. Write an exponential function. Okay, my generic is y equals a parentheses b raised to the x. Now, I need to plug in my numbers. Quadruple, that is a number. It's 4. And 5 is my starting value. So my formula would be y equals 5 because that's my initial value. My multiplier is 4 because it said quadruple, and that means 4. And then we raise it to the power of x. Now notice the x is up in the sky. The x is an exponent. That's why it's called an exponential equation. X is not on the line of notebook paper. If x is on the line of notebook paper with your y and your m and your x, then you have a linear equation. An exponential equation is going to have x up top raised above as an exponent. Now, how many bacteria are in the bottle at 3:41? Well, hold up. 3:41 minus 3:30. That is the number of minutes that we're actually looking at. So how many minutes are between 3:41 and 3:30? Well, that would be 11 total minutes. So this is what we're going to plug in for our x. We're going to plug 11 in. So it'll be y equals 5 times 4 to the 11th power. And you're going to plug that into your calculator. Does it tell us how to round? No, because we're going to get an integer. All right, let's see. 4 raised to the 11th times 5. Wow. Humongous number of bacteria. 2, I'll write it and then I'll read it. 2097152. You put a comma after each third digit. So we've got 20,971,520 bacteria in 11 minutes time. Speaking of, real quick, I heard somebody say that if you captured all the COVID bacteria in the world, every COVID bacteria in the world would fit in a soup can. That's what I heard. And so bacteria multiply very, very rapidly. Moving on, number 14. The population in a Texas town is modeled by the function blah, 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 blah. If the initial population, okay, the initial population is when time started. This is the starting time, okay? In other words, no time had passed. It is the initial time of this town. It was measured on January 1st, 2013. What is the initial population? Okay, wait, don't overthink this. All they're asking is what is the initial starting population of this exponential function. Here's your function, and they want to know which of those numbers, 10,944 or 1.043, which is the initial value. Well, we know that this is our A. This is A, and A represents the initial value. So the answer here is 10,944 people were in this town originally, in the beginning, when the first, I guess, survey was taken in January 1st, 2013. There were 10,944 people. B, your multiplier, is 1.043, but we weren't asked about that. So that's the answer to that question. Okay, you will see that question again on Hawks. You will see that question again on your quiz. So heads up, be prepared. This is the same question, I think. The total attendance of a contemporary art museum is blah, blah, blah. Here's your formula right here. We do have an exponential because X is in the sky. X is elevated. If the initial total attendance, blah, 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 at the starting time, okay, this is your starting time. Right here it says X equals 0. What will be the total attendance? Oh, I'm sorry, different question. What will be the total attendance on January 1st, 2029? Well, we've got to determine our time. So if we do 2029 minus 2013, that is how many years we're looking at here. So that's going to be 16 years. 16 years is what we need to plug into our formula. So we're going to take 16 and we're going to plug it in right here for this X. We're going to plug 16 in for X. So 13,221, 1.049 raised to the power of 16. Now it says round to the nearest whole number because we are talking about human beings. We are talking about people here. And as I've said before on a previous problem, you cannot have a decimal of humans. So put it in your calculator using your PEMDAS rules and multiply. And I'm getting 28,423 human beings. That's how that would round. The number after 3 is a 1. So it'll stay at 423. That 1 does not bump it up. Still having some rounding issues. Last one, I appreciate you hanging with me on such a lengthy lesson. A new company started with 0 customers. Every year they gain 42 customers. Write a linear function. Okay, so we know we're dealing with y equals mx plus b. We know that m is our rate. And we know that b is our initial or our starting value. Also known as your y-intercept. M is your slope. So m is the rate. Well, this company is gaining customers at a rate of 42 per year. X will be our number of years. And it says that they had 0 customers when they started. Well, that makes sense because if it's a brand new company, on day 1 when you open the doors, you don't have any customers. You might have a customer that walks in the door that first second, but when it started initially, you had 0 customers. So I'm going to put a 0 here. Now, that doesn't look very intelligent. It doesn't really look like we know what we're talking about. So I would rewrite my final answer as just y equals 42x. This particular problem would not have a y-intercept. How many customers will they have in 8 years? X is our number of years. So we plug in 42 times 8. I'm sorry, X is our number of years. X is 8. 42 times 8, 336 customers at the end of 8 years. And the final question, how many years will it take for the company to have 693 customers? Company customers, a lot of C's going on there. Okay, this is a little bit different. We don't know the time. We don't know X. So we need to plug in 693 for Y. And then we're going to solve our formula for X. The only thing we have to do here is divide both sides by 42 because the opposite of multiplying is dividing. And this will tell us how many years it will take to get 693 customers. And I'm getting 16.5. I'm going to leave that as a decimal. It might make more sense to say 16.5 years. That might make more sense. And then if you think of that really in terms of time, half a year is 6 months. So we would have 6 years and 6 months before we got our 693 customers. I would accept any of these 3 answers, but you should know that they are all the same. So 16.5 is the same as 16.5 years, and 16.5 years is 16 years and 6 months. Okay? Okay, make sure you've watched all my videos, part 1, part 2, part 3, and that should carry you through the next 2 weeks.